Okay, picking back up with the second part of our video. Okay, I'm going to let number 7 here be a U try. So copy this problem down, and I want you to get a common denominator. Then once you get that common denominator, focus on the numerator, and then verify your solution. So let's take about 2 minutes because this one's a pretty short and easy one. Alright, so let's see what you did. Alright, so going through our steps, we know we want to end up with a common denominator. So going through step 1, it says factor the denominator. Well, I can kind of look at it and see what I need here, but I'm going to go through the process of using those steps. I see that both of these have a p in common, so I'm going to pull a p out. If we have 2 p's, because we got p squared, and we take 1 out, then we're left with just 1p. If we have 6p and we take a p out, then we're left with just 6. And these two are the same, so we know the same scenario would happen here. So this would be p times p plus 6. Well, what do these two have that this one does not? This one doesn't have a p, so we're going to have to come in here and multiply the bottom by p. Then if we multiply the bottom by p, then we got to multiply the top by p. Now we've got that common denominator, so we're going to focus on just the numerator. Alright, so this is going to give us, just focusing on the numerator now, this is going to give us 5p minus 1 equals 2. We're going to add 1 to both sides. We get 5p equals 3, and then we divide by 5. So p equals 3/5. Alright, if I substitute in a 3/5 for p, 3/5 plus 6 is not 0. 3/5 squared plus 6 times 3/5 is not 0. So this is not an extraneous solution. This is an actual solution. Now, just to verify that this is correct, let's practice putting this in Desmos. Alright, so remember, left side, right side. When you're trying to solve an equation, you do left side, right side, and see where they intersect. The x value of their intersection is the solution. So I'm going to come right here. I've got a fraction here, so I'm going to hit the division bar so I can get my fraction. So I've got 5 over, alright, I can't use a p, I've got to use that x. So I'm going to say x plus 6, cursor to the right, minus, hit that fraction bar, the division to get that fraction, 1 over x squared plus 6x. Alright, so that's the left side. Now let's look at the right side. Alright, hit that fraction bar, or the division to get our fraction bar. So we got 2 over x squared, oops, try that again, x squared plus 6x. Alright, we want to see where they intersect. So coming right here, and I know it's harder to tell the difference between the colors. Let me change this to maybe an orange. I think that's a little easier to see. If you just tap one of the equations, it'll show you certain points of interest. Okay, like here we got a vertex. Here, right here, I can see their intersection. So when I tap that, I get 0.6. Now, we've got our answer as a fraction, and I want to see if that fraction is the same thing as that 0.6. So I'm going to come right here and I'm going to say 3 divided by 5. Does that give me 0.6? Well, the answer is yes. So my fraction that I got right here is the same answer as the point of intersection. So that lets me know that is correct. So as I said, on that set exam, which is coming up in about 3 weeks, the two main things that we do with Desmos is verify that things are the same or equivalent by doing the original problem in line 1, the answer choice in line 2. If they're the same graph, that's the answer. But if it's an equation like it is here, because we have the equal sign and we're asked to solve, we do left side, right side, and see where they intersect. All right, copy this problem now and we'll get started on it. So again, as you're copying this down, remember this is an equation. So if we just completely forget what we're doing and how to solve it, left side, right side, and see where they intersect. On the state exam, they're not going to ask for the work. They're not going to grade your work. They are actually going to now ask for the work. We have to submit your scrap paper, but they're not going to grade your work. They want to simply look at your work, supposedly. All right, about 45 more seconds of copying this down. All right, so step 1 says factor your denominator. I can't factor it here because it's already in simplest form. This one's in simplest form, but I do need to factor this one. So let's come right here. Fortunately, there's no leading coefficient, so we know x squared came from x and x. And 3, the constant of 3, only has one set of factors, and that's a 1 and a 3. The middle sign usually goes with the largest factor, so we're going to put a negative right here. And then ask yourself, what kind of 1 times a negative 3 will give us a negative 3? Well, if we let that be a negative, is a negative times a negative a negative? No. So that lets us know this should be a positive, because a positive 1 times a negative 3 is a negative 3. A negative 3x plus 1x is that negative 2. So now let's see what we got in common. All right. These two each have one binomial factor that's in common with this one. So we're going to ask ourselves, what does this one right here need that this one has? Well, it has an x minus 3. So if we multiply the bottom by x minus 3, then we need to multiply the top by x minus 3. What does this one right here need that this one has? Well, it needs an x plus 1. So if we multiply the bottom by x plus 1, then we're going to multiply the top by x plus 1. Okay. Now that we've got common denominators, we're going to focus only on the numerator. Alright, so coming right here, 5 times x is 5x. 5 times negative 3 is negative 15 equals 6. 1 times x plus 1 is simply x plus 1. Alright, combining like terms, I get 5x minus 15 equals 6 plus 1 is 7, so we get x plus 7. I'm bringing my x's to one side and my constants to the other. So I'm going to subtract x from both sides here. And then I'll add 15 to both sides. 5 minus 1 is 4. These cancel. These cancel. And 7 plus 15 is 22. Dividing by 4, we're going to get x equals, all right, this is going to reduce 22 over 4, reduce it by 2 is 11 over 2. All right, so let's ask ourselves, going back to the original problem, if I do 11 halves plus 1, does that give me a 0? No. If I do 11 halves squared minus 2 times 11 halves minus 3, does that give me 0? No. If I say 11 halves minus 3, does that give me 0? No. So this is not an extraneous solution. And again, if you can just completely forget how to solve it, and you want to, or you simply want to verify your solution, you can go to Desmos and do left side, right side of the original problem. So my original problem here on the left side is 5 divided by x plus 1. Alright, my right side.
No.
Alright, for the right side, we've got 6 divided by x squared minus 2x minus 3, cursor to the right, plus 1 divided by x minus 3. Alright, hold on. Alright, let's try this again. Alright, so if we just tap it, we see some points of intersect. I mean, some points, some critical points, but we want to look for where they intersect. So they intersect right here. That's 5.5. Well, we know 11 halves is 5.5, so we know that is correct. So that is not an extraneous solution. So if you'll copy this down, and yes, that's my little Dachshund, Remy barking. All right, about 45 more seconds. Now, as you're copying this down, if you are not practicing with me when I'm putting this in Desmos, if you are not practicing on verifying your answers at home when you do your homework, then when it comes to test time for the EOC, you're going to not have enough practice to be more than a novice in using Desmos. Now, this year, about 3 weeks ago, DPI, or state legislators, powers that be, made it so that, created a law that stated that teachers cannot give their own state exams. So somebody else is going to be giving you your exam. I'm not allowed to give my exams. But even if I was allowed to give my own exam, I'm not allowed to tell you how to use Desmos. I cannot answer any questions. So you need to practice with Desmos. Okay, so again, make sure you practice with Desmos. Make sure you know your formulas. Any formulas that we've used, especially the circle formulas. Make you some note cards. Start practicing with those formulas. All right. So now let's work on step 1, getting anything factored. Well, here, there's nothing to be factored, right? But I do see a whole number. So we know whenever we have a whole number, that's an understood denominator of 1. We want to get a common denominator, which is step 2. Well, if you notice, these two have k's in them, so this one needs to have a k. All right. So before I work on this one, I'm going to get this one the same as this one. What is this one missing that this one has? Well, it's missing a 4. So if I multiply the bottom by 4, then I've got to multiply the top by 4. So we end up with 4k. Now, one really nice thing about this is that if this is a 1, whatever your denominator is, that ends up being the denominator of the denominator for a 1. And that kind of made no sense to some of you. Some of you may have made sense. Okay. So here, we know we want a 4K here. So what is this missing? It's missing a 4K. So I've multiplied the bottom by 4K, then I'm going to multiply the top by 4K. Well, we know anything divided by itself is 1. So the shortcut, when you have a denominator, well, excuse me, when you have a number that's just 1, a constant, you can say denominator of denominator, change it into that 1, and not change the value. Alright, so now that we've got our common denominators, let's focus only on the numerator. Alright, so let's focus on just the numerator. Alright, so 4 times k is going to give us 4k. 4 times 1 is going to give us 4. 4k times 1 is still 4k. And then right here, we've got minus all of this right here. So we've got to be very, very careful about this. This is minus all of this right here. So what that minus is, when it's in front of a term, it means the opposite of all that. If it's in front of a single term, then it's just minus, it's subtraction. But here, since it's in front of a more complex term, then it's taking the opposite of all this. So the opposite of positive k squared is negative k squared. The opposite of negative 3 is positive 3. And the opposite of negative 4 is positive 4. So let's combine any terms that we have that are like. So we got 4k plus 4. Right here I got my k, so we got negative k squared. 4k plus 3k is 7k. And then bring down our constant. Okay. We can see that we've got a quadratic here. So I'm going to move everything to one side. Now, I usually like to keep my quadratic term positive, so I'm going to move everything over here. So I'm going to add k squared to both sides. There's no k squared over here. I'm going to subtract 7k from both sides. And then I'm going to subtract 4 from both sides. Alright, k squares cancel, the 7k's cancel, and the 4's cancel. So over here on the right side, we'll get a 0. I have no other k squared, so I'm bringing down the k squared. 4 minus 7 is negative 3k, and these 4's cancel out. So what we have here is a quadratic binomial. It's quadratic because it's to the second power. It's binomial because it has 2 terms. And if you notice, both of these terms have a k in them. Alright, so we're going to factor that out. You could use quadratic formula and do 1, negative 3, and 0, but here I'm just going to use the zero product property, which says factor it, and then set each factor equal to 0. So they have a k in common, so when I pull that k out, if I had 2 k's and pull 1 out, I'm left with 1. If I've got a 3k, so I got 1k, and taking out that 1k, I'm left with just the 3. So then I take each one of these and set it equal to 0. That's your zero product property in use there. So I got k equals 0. And then when I add 3 to both sides, I get k equals 3. Now, as I said earlier, we've got to test to see if these are extraneous solutions. And remember, extraneous solutions are solutions we get that create a point of discontinuity. It creates a 0 in the denominator, which means it disconnects the graph. Alright, so if I put a 0 into the original problem, I would end up with a 0 in the denominator. 4 times 0 is 0. So I cannot have a 0 in the denominator, so that means that 0 is an extraneous solution. Alright, now when it comes to testing, whether it be on my quiz, my test, or the EOC, always make sure that you read your directions. Sometimes they're going to ask for what are the extraneous solutions? What are the extraneous solutions? Okay, if that's the case, then your answer would be the 0. But if they ask what is the solution, you don't want the extraneous solution, you want the actual solution. So the actual solution here would be 3. Because if we substitute in a 3 right here or right here, we don't get a 0 in the denominator. I know you're thinking, how many more examples? Well, we've got just 2 more examples and we'll be done. As long as Remy quits barking at everything. Now you can see why I usually make my videos very late at night, because usually Remy's asleep. Alright, so that was number 9. So let's see, number 10. Alright, so copy this down. And if you hear that little tap, 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 I'm not sure how good this microphone is. That little tap, 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 tap is my other Dotson. He's 16, and he just walks around because he's nosy. And that is his little claws tapping on the wood floor. Tap, 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 tap. Alright, now that you got this copy down, I want you to pause the video for about 3 minutes. I want this to be a U-try. It's going to be very similar to a problem that we've already done. So pause it for about 2 to 3 minutes and give it a try. Alright, so let's see how you did. If you notice, I don't have to factor these because there's nothing to be factored. They both are already 5n, but I need this one also to be a 5n. Well, since it's a 1, this is going to make it really easy. If I do 5n divided by 5n, anything divided by itself is 1, so I essentially just use the denominator to change it into a 1. Now, if this was a 2, you would multiply. If this you would multiply the top by 2, but you would still do denominator over denominator. Then they just multiply the top by 2. Now that we got common denominators, we're going to look at just the numerator. Alright, so let's see what we got. We've got 2n squared minus 8n minus 10 minus 5n equals n plus 6. We're going to combine like terms. So it gives us 2n squared. Negative 8 minus 5 is going to give us negative 13. Bring down the minus 10 equals n plus 6. Now, since this is a quadratic, we want to bring everything to one side and set it equal to 0. Alright, so I'm going to subtract n from both sides. And I'm going to subtract 6 from both sides. Alright, these cancel out. And over here on the right side, I get 0. Bring my 2n squared down. Negative 13 minus 1 is negative 14. Negative 10 minus 6 is negative 16. Alright, so we got that quadratic. Now I notice this quadratic, everything is even, so I can actually simplify this by dividing every term by 2. And when I say every term, I literally mean every term. These divide out and give us 1. I'll come right here. So I get n squared. 14 divided by 2 is 7. 16 divided by 2 is 8. Now that's a much nicer looking trinomial to factor. All right, n squared comes from n and n. 8 is either 1 and 8 or 2 and 4. Which one of these would give you a 7 by either adding or subtracting? That would be the 1 and 8. The middle sign is negative, so that goes with a larger factor. And what kind of 1 times a negative 8 would give us a negative 8? That would be a positive 1. All right, because positive 1 times negative 8 is negative 8, and negative 8n plus 1n would give us that negative 7. So thinking about this is in factor form, remember? So we can kind of look at this and think, well, this is x minus your root. And we know that roots are x-intercepts, which are zeros, which are solutions. And that's what we're looking for. We're looking for solutions, right? So here, n is either going to be negative 1 or n is going to be 8. Now, since this was a quadratic, we want to make sure that we verify our solution. So if we say 5 times negative 1, is that going to give us a 0? No. If we say 8 times 5, is that going to give us a 0? No. So both of these happen to be our solution. So negative 1 and 8 are their solutions. All right. And finally, for our last one. Now this is the doozy. It's going to look nice and simple, but it is the doozy. So make sure you notice how I space the problem when I write it down. All right, about 30 more seconds to write this down. And this is the last problem. All right, notice that none of the denominators are the same. So what does this one right here need that the other two have? Well, it needs an x minus 2 and also needs a x plus 1. But if I multiply the bottom by these, I got to multiply the top by these. All right. What does this denominator need that the other two have? Well, it needs an x minus 1 and it needs an x plus 1. If I multiply the bottom by those, then we got to multiply the top by those. And then looking at this last denominator right here, all right, what does this denominator need that the others have? Well, it needs an x minus 1 and an x minus 2. But if we multiply the bottom by these, we got to multiply the top by these. And I did kind of reverse it here, but remember, with multiplication, the order doesn't matter. So they still will be the same thing. So like if this was 8 times 4, that's 32. If I did 4 times 8, that's still 32. All right, so we've got our common denominator, so now we're going to focus on the numerator. So here comes the fun part. Look how big that numerator is. There's a whole lot right there. Okay, so I'm going to come right here. I'm going to FOIL these first right here. So I got 6 times x is x squared. Negative 2 times x is negative 2x. And then x times 1 is positive 1x. And combining these, we get negative x. Negative 2 times 1 is negative 2. All right, looking at this one right here. X times x is x squared. Negative 1 times x is negative x. X times 1 is positive x. And if you notice the x's there, they cancel. So we're left with the negative 1 times 1, which is negative 1. And I'm going a little fast, aren't I? Alright, and now looking at our last one, 4 on this last one. X times x is x squared. X times negative 1 is negative x. Negative 2 times x is negative 2x. Negative 1 minus 2 is negative 3. And negative 2 times negative 1 is positive 2. So, whew. Now that we got everything foiled, now we're going to use our distributive property. Alright, 6 times x squared is 6x squared. 6 times negative x is negative 6x. 6 times negative 2 is negative 12. 4 times x squared is 4x squared. 4 times negative 1 is negative 4. 2 times x squared is 2x squared. 2 times negative 3 is negative 6x. And 2 times 2 is 4. Alright, so combining some like terms over here. We've got 6x squared minus 6x minus 12 equals 4x squared plus 2x squared is 6x squared. That's not another x. I'm going to come right here and put minus 6x. Negative 4 plus 4. Well, they cancel out. That makes it convenient. Alright, since this is a quadratic, I want to move everything to one side. So, opposite of positive 6x squared is negative 6x squared. Opposite of negative 6 is positive 6. These cancel, these cancel, these cancel, these cancel, and I get negative 12 equals. Well, these canceled over here, so most of the time we think there's nothing there, and it's true, there is nothing there. What represents nothing? Well, that is a 0. We've got negative 12 equals 0. We don't have any variables left. When you have a scenario where the equation ends up with no variables, you've got a possibility of two different answers. If it's a true statement, your answer is going to be all real numbers. If it's a false statement, your answer is going to be no solution. Does negative 12 equal 0? No, that's false. So since it's false, it's going to be no solution. So here we would simply say no solution. If this were to have said negative 12 equals negative 12, then that means that every single value of x would be a solution. So it would be all real numbers. Now, let's see what this looked like on Desmos real quick, and then we'll be done. So make sure you got Desmos open and practice it with me. All right. On the left side, and we're just going to do the original problem. We've got 6 divided by x minus 1. On the right side, we've got 4 over x minus 2 plus 2 over x plus 1. All right. We want to see if we have any intersections. Now, just so that it looks a little better, I'm going to make these lines a little thicker. Alright, now it might look like they intersect, but remember I said if you touch the graph, you should see points of intersection. Alright, I don't see a point of intersection. I don't see that little dot popping up. Although they're very, very close, when you look at them, they're still not there. Alright, now I try to make it a little bit thicker. It looks like one's on top of the other, but again, they're so close together, they look like they're intersecting, but they are not intersecting. Okay, and then coming right here, looking at the right side. Again, I'm tapping this to see if I see that little gray dot pop up that represents the point of intersection, and we don't see it. So they are not intersecting, so that's no solution. Now, if it was all real numbers, then they would be the exact same graph. Everything would match up perfectly. Alright, so again, how do you know when you're going to have this scenario? Either when you have the left side equals the right side and there's no variables, that would be true, so it would be all real numbers. Or if there's no variables left and the left side does not equal the right side, then it's a false statement, there's no solution. And that, ladies and gentlemen, is the last of our problem.